Next, we will discuss the chain rule for differentiation. The chain rule states that the derivative of a composition of two functions is equal to the derivative of the outer function in terms of the inner function multiplied by the derivative of the inner function. This is the rule stated in Newton notation, and this is the same rule stated in Leibniz notation. The chain rule can be applied for compositions of any finite number of functions. Here is the rule written for three functions in Newton notation. The goal is not to memorize the rule but to understand the process, and the chain rule written in Leibniz notation is actually very intuitive. Let's, for example, find the derivative of the following function. We start the process by recognizing that we have to find the derivative of a composition of the square root applied to a quadratic function, which is equal to the following expression, in which we know how to find all the components. We get the final answer after plugging everything in and simplifying. Let's do another example. We start the process by recognizing that we have to find the derivative of a composition of the cube function applied to a quadratic function, which is equal to the following expression, in which we know how to find all the components. We get the final answer after plugging everything in and simplifying. We discussed the chain rule for differentiation and how it makes it possible to find the derivatives of compositions of functions.